Today, I'm going to go ahead and go over with you significant figures. Now, significant figures have rules. And the purpose of significant figures is to convey meaning about the precision of a measurement. Now, I'll say that again for you. Significant figures convey meaning about the precision of measurement. Now, I'm going to give you an example of some rules with significant figures. First rule. All non-zero numbers are significant figures. Each number in here has a significant figure because they're all non-zeros. So here we have 1, 2. And I'm going to denote significant figures as sig figs. This one here has 3, 5, 2, and 4 each. And this one here has 2. Now, next, zeros can count as sig figs if they're in between two non-zero numbers. So let me go ahead and get that fig. An example of this would be 202.0. The zero in between the 202 will count as a significant figure. So here we will count the 2, the 0, and the 2. Now, in this example, you won't count these two. These two here are just placeholders. So you'll start with the 5, count this 0, 3, and the 2. So this one will have 4 significant figures. In our previous example, we'll have 4 significant figures because the 0 follows the non-zero number. So we'll count the 2, the 0 in between these two values, the 2, and then this other 0 that follows. And this example right here leads to my next rule. Zeros following any non-zero number are considered significant figures. So, in this example, 40 would have 4 significant figures because these three zeros follow the 4. In another example, goes decimal. Here, you would have 3 zeros that are also significant figures because they follow the 5. So in total we'll have 1, 2, 3, 4 significant figures. I didn't mean to erase that.
About 14 days.
Next, the number 0 is most often considered a placeholder. The 0 is also considered a significant figure when it's by itself. So when 0 is always by itself, it's a significant figure. And now the other rules that we're going to go through are what makes a number not a significant figure or a 0.
Here it is.
Now, numbers leading in from the right side of the decimal are not considered significant figures. Now, we went through an example like this earlier. I'm going to give you another one right here. These 2 zeros right here are only placeholders. And are not considered significant figures. So the 6, the 0, 3, and 2 are considered significant figures. So that would give you 4 significant figures. Another case that comes up often are ambiguous numbers. In this case, numbers are not given a decimal place or a stopping point with zeros at the end. So for example, these numbers right here are considered ambiguous because we never know when the number stops. We're never given a decimal point, a bar, anything. So, if you're ever asked to find the significant figures of a number ending in zeros, you go ahead and write down ambiguous. Now, if you do have an ambiguous number such as, let's say 3,000, you can label where the significant figures stop with a bar under the number. At this number, this would be considered the last significant figure. So 3, the 0, and the 0 are all labeled as significant figures. So you'd have 4 significant figures. Now, if you're given a large number, the bar is right here, and the significant figure would be stopping right here. So you'd only have 2 significant figures. Bam. Now, another way of labeling an ambiguous number of how many significant figures it has is by placing a decimal. Now here in this number, you can place a decimal at the end, which tells you where you can stop. So here you have 1, 2, 3, 4, 5 significant figures. Wow. Okay. Now a reminder, within the video, significant figures convey the meaning about the precision of a measurement. a quick review. Now, when we're working with logs and exponents, significant figures can often be looked at a little differently. We're given the numbers. Negative log, base 10. Once you evaluate this number right here, you'll be given around 1.345. Now, working with logs or exponential functions, this first number will not be counted. This can also be called characteristic.
Yeah, I mean,
so this number,
it's weird. The people who think that they are not even close are going over.
it's not counted.
They are way over.
3, 4, 5 are considered significant figures, so you would have 3 significant figures. Now we're working with exponents. The first number, which is a characteristic, will not be considered, just like the logs. And the last 3 numbers, in this case, will be the significant figures. So you have 3 significant figures in this example. In this case, looking at exponential functions and logs, the decimal place right here is called the mantissa, which in this case will begin counting of the significant figures, which is the 6, the 7, and 3, 3, 1, 2, 3. So 3 significant figures. Now to review before I close. Significant figures.
It was greater than 6 units. It was greater than 9 units.
Was greater than the first one?
Are all 0 numbers? Or all non-zero numbers?
Oh.
All zeros?
No, it's informed.
Between non-zero numbers?
You can add on when you have in your computer.
And numbers trailing non-zero. Numbers that are trailing, scratch that, are 2 on the left of the non-zero are not. And with logs and exponentials, first character does not count because the character is just a count. And that concludes lesson today, significant figures.